Hello everyone, my name is Harsha Bujunuru. Today I will be presenting about my project titled Secure File Transfer System, a project which is developed to provide a secure and efficient way to transfer files over the internet while at the same time ensuring confidentiality, integrity and authenticity which are necessary in every network security application. So let's dive through. So in this presentation I will cover several important aspects of the Secure File Transfer System application which I have developed. I'll start by introducing the project, followed by why secure file transfer is important in today's world. After that, I will compare existing solutions and highlight their limitations. I'll also talk about the project's objectives, system architecture, and the cryptographic algorithms that are used in the development of this system. And then I will cover about CIA Triad, how it's implemented in our project, and why I have chosen AES encryption over other algorithms. We'll then discuss the need for digital signatures and evaluate the strengths of the system and then discuss the future directions for this project. So, coming to the introduction, in today's digital world, data is constantly exchanged over the internet, whether it is sensitive personal information or business data or intellectual property data. Ensuring the security of these transfers is very important. However, traditional methods are vulnerable to various types of attacks. That is where the importance of security file transfer system comes in. The main goal of this project is to create a system that provides end-to-end security for file transfers, preventing unauthorized access and ensuring that files are not tampered with during the process. And also one of the goal was to design user-friendly interface for users to interact with the application and also offering robust security features. So why secure file transfer is needed? So as I mentioned previously, sensitive data is transferred globally every day, whether it's for personal use, corporate purpose, or financial transactions. Any breach during this transfer can have severe consequences like identity theft, data theft, business losses, and reputational damage. So traditional transfer methods like email or FTP are prone to man-in-the-middle attacks, where an attacker intercepts and possibly alters the data transmission. In contrast, I have tried to develop a secure file transfer system which ensures that only the intended recipient can read the file, preventing unauthorized access and ensuring data integrity throughout the file transfer process. And moreover, many regulations like GDPR, for instance, and HIPAA and PCI DSS require requires and asks for organizations to protect sensitive data during transfer, making secure file transfer a critical necessity nowadays. So I'll now explain about the existing solutions and their limitations. So as we can see, these are the following existing solutions which are available in the market for the file transfers. As we all know, we regularly use email, but email lacks proper encryption, leaving the file vulnerable to attacks like eavesdropping. In addition, email attachment can easily be intercepted, altered, and deleted. Coming to FTP or SFTP, these protocols offer some level of security, but they are not the most user friendly. They also require a server, which can be difficult to manage for non technical users. And cloud storage options like Google Drive or Dropbox offer some sort of security, but rely on a centralized service, which poses risk. The service provider also has access to the data, and there are concerns about platform lock-in and data privacy. And the commercial solutions which are available offer encryptions, but they come with high costs and limitations. They're also often closed source, which raises questions about transparency. So, our secure file transfer system overcomes all these gaps. Now, coming to the project objectives, these are as follows. One is secure file transfer. So we aim to provide a system that allow users to upload, encrypt and transfer files securely, and it is achieved using AES encryption for files and RSA encryption for key exchange. And also the most important thing is user-friendly interface. The system is designed to be easy to use even for people with limited technical knowledge, and it allows for users to register, log in, upload files, and verify the files they receive with minimal steps, and also ensuring the integrity of file by using digital signature, and each file is signed with sender's key, ensuring that it hasn't been tampered with during the transmission, and the receiver can verify the signature using the sender's public key. And also, users can be able to access the app globally through ngrok, which we have used, which enables secure global access to the system. So that were few of the project objectives which I have kept in mind during the development. Now coming to system architecture. The system architecture consists of four main components. One is a front-end component, second one is a back-end component, third is a database MongoDB component, and fourth one is the security layer component, which is cryptographic components. Coming to the front-end component, the front-end is built using HTML, CSS, and Bootstrap for responsiveness. It includes pages for users registration, login, file upload, and file transfer. Coming to the backend is built using Flask. It is a Python-based web framework and it handles user authentication, file encryption and decryption, RSA key management, and signature verification. And in the case of database, we have used MongoDB and it stores user data, encrypted files, and signatures. The files are stored in encrypted form, and only the encrypted AES keys are also stored, ensuring data confidentiality. Coming to the cryptographic components, which offers security layer, AES is used to encrypt the file contents, and RSA handles the encryption of the AES key, and digital signatures are used to verify the file authenticity and integrity. And as I mentioned, global access is provided through ngrok. Coming to the CIA triad, which stands for confidentiality, integrity, and authentication, as we all know. Confidentiality is achieved through AES-256 encryption, which ensures that only the intended recipient can access the file contents, and the AES key is securely encrypted using the receiver's RSA public key before it's being transmitted through the file transfer. And integrity is achieved by the use of SHA-256 algorithm to hash the file before signing it, ensuring that the file is not modified during transfer. If it is modified, then the signature verification will fail, indicating tampering and data theft. And one more thing is authentication. How it is achieved is each file is digitally signed using the sender's private key, which provides the origin of the file, and the receiver can verify the signature using the sender's public key. And the bonus of this is it offers non-repudiation, like the sender can't claim that he hasn't sent the file. Coming to the cryptographic algorithm which we made use of in this project, one is AES-256 version because of its speed and security. It is symmetrical encryption algorithm, as we all know. Means the same key is used for both encryption and decryption. And we have made use of RSA for key exchange. It is an asymmetric encryption algorithm and it allows for secure key exchange and ensures high security. And SHA-256 is used to hash the file, which is required before signing the file, and it ensures file integrity. And the signature ensures that file hasn't been tampered with during transmission. And we made use of public key cryptographic system. It is a framework for signing the file and verifying its authenticity. Coming to the point, why specifically AES algorithm is used and why not other algorithms? We have chosen AES to specifically because of its optimal speed and security. And AES is very fast, and one more main advantage is it is highly resistant to cryptanalysis attacks. Coming to the alternatives which I have considered before finaling on AES where DES, which is data encryption standard, it is a bit outdated and only supports a 56-bit key, making it vulnerable to brute force attacks. Blowfish. While Blowfish is fast, it doesn't provide the same level of security as AES, especially for large file transfers and large data sets. And one more one is Cha-Cha 20. While it's good for mobile devices, it is not as widely trusted or supported as AES. AES stands out among all this because it's secure, fast, and widely supported across multiple industries. So why digital signatures? Digital signatures are an essential part of the system because they provide proof of origin, means the receiver can be sure that the file originated from the sender And the signature is unique to the sender's private key because only he has that. And also integrity. If someone modifies the file during the transmission, the signature will fail to verify, indicating that the file has been tampered with. So is also accountable. Accountability is achieved through non-repudiation. The sender cannot deny the file being sent by him because he used his private key to sign it, and the signature serves as a proof of his evidence. So that's the reason for the use of digital signatures. Coming to the technologies used, as I previously mentioned, I have made use of Flask for the backend framework, which handles requests, manages user sessions, and processes file uploads. And MongoDB NoSQL database is used to store user data, encrypted file data, and encrypted signatures and key. And also Bicrypt library, which I have made use for secure password hashing. And PryCryptodome library offers is used to implement AES, RSA, SHA-256, and digital signatures. And also Bootstrap framework for responsive and clean UI, and ngrok for securely exposing the local Flask app to the web. This is a process workflow diagram of my application. First, it starts with the home page where is provided with the options of registration and login. The user registers by providing his username and password. The system generates RSA keys for the user and stores them securely as soon as he is registered. Then the user logs in, and file uploadation is done by him, which is encrypted using AES, and then the AES key is encrypted using RSA and sent to the receiver after digital signing. Mm, Then file transmission occurs, and the receiver then decrypts the file using their RSA private key, verifies the signature, and ensures that the file has not been tampered with during the transmission. This is a process workflow as I just mentioned. This is the application home page for my application, and this is the user register page, and this is the user login page, and this is the user dashboard page with sender options and receiver options if the user acts as a sender and acts as a receiver also. So why ngrok is used in our application? It is used to make the system globally accessible even though it is running locally. As I have made local development of my project, in order to make it globally accessible, I have made use of ngrok. It creates one of the unique feature of ngrok. It creates a secure tunnel from our local machine to the internet, allowing external access to the application. And its configuration is pretty straightforward. It offers zero configuration, and it automatically handles all the networking and security aspects. So that's the reason for using ngrok. Coming to the evaluation and security strengths of my project, there are several strengths like AES ensures fast and strong encryption for the files. RSA enables secure key exchange and makes it impossible for attackers to intercept or decrypt the key. And the system is also designed for user-friendly operations. With minimal steps, they can process the file transfers. Even the non-technical users can easily use the app. And also, system guarantees end-to-end encryption through which confidentiality is achieved, and key security is achieved through integrity, through digital signatures, and also authentication of the sender using their private RSA key, which ensures signature verification. Coming to the current features and the future scope of the project is currently the implementation can handle large file transfers by breaking them into smaller parts, like usually file chunking, ensuring smooth file uploads and download without memory overflow or timeouts. And one more one is a multi-device support. Because of the web-based nature of the app, it makes it easily accessible across multiple devices, irrespective of the platform, like Windows, Mac OS, Linux, and or even the mobile device can access the app. The future enhancements for the project can be TLS integration for additional transport layer security, and also auditing audit the logging to track system usage and monitor for potential breaches or suspicious activities. So, coming to the conclusion, the secure file transfer system effectively integrates AES encryption, RSA key exchange, as I mentioned, and digital signatures to ensure the file transfers are secure, efficient, and reliable. With the help of Ngrok, the system provides global access without need for complex infrastructure. So now I'll quickly go through the demo of the project. As you can see, the project is running at port 5000 and Ngrok is already enabled to listen the traffic at port 5000. Now I'll open the application. Yeah, I've already created two users name user 1 and user 2. So I'll proceed with the login as user 1. So now I'll select a file to upload. I'll select this file, data reliability in IoT, and then upload and encrypt that file. As you can see, it shows file upload and encrypted using Gridfizz. Then I will child this file and then enter the name of the recipient user. Then send file to receiver. Okay. Since he has no options available, like no files currently received, he's not able to select a file. See, no files received. Now I'll log in as user 2. Login, and as you can see, since he received the file, he can have the have a look at the drop down and then select the file. First, verify the signature before the decrypting and saving it. See, the signature is verified successfully, and then we can now decrypt and save the file. I will choose a name as data reliable DT, decrypt and save file. As you can see, we have saved the file and it is decrypted correctly. So that's it. Thank you for uh, having you all with me in this presentation.